The graph of the piecewise linear function y equals f of x is shown on the left, and the graph of the piecewise function y equals g of x is shown on the right. Part A, find f of 2 plus g of 1. Part B, find g of f of 2. Part C, find f inverse of g of 2. Part D, find the domain of f of x divided by g of x. And Part E, use 3 rigid transformations to write g of x in terms of f and x. So let's start with the first one. We want to find f of 2 plus g of 1. That will be equal to find f of 2, you go to x equals 2, and you go up, and f of 2 is equal to 3. To find g of 1, you go to this graph right here, you go to x equals 1, and g of 1 turns out to be 4. So 3 plus 4 is 7. Next question, find g of f of 2. Once again, you start on the inside, so this will be g of whatever f of 2 is equal to. To find f of 2, you go to x equals 2, and you go up, and that is 3. So this will be g of 3. To find out what g of 3 is, you go across to this function and plug in 3, and when you do so, you get 1. Next question, find f inverse of g of 2. So in this particular case, you want f inverse of whatever g of 2 is. To find g of 2, you go to the g of x function, and you plug in a x equals 2, and when you do so, you get 3. So this is f inverse of 3. In order to find f inverse of 3, this time instead of going to the x-axis on the function f, we go to the y-axis and take 3 and reverse the process. Come across here and down, and we get 2 for f inverse of 3. Find the domain of f of x divided by g of x. Well, in this particular case, f of x is defined between 0 and 2, and g of x is defined between 1 and 3. So what we would like is we would like the intersection of those two. So that domain will be the set of all x such that x is a real number and x falls between 1 and 2. You will notice that, if you're being careful, the denominator g of x, which is this function right here, on the range from 1 to 2 is never going to be equal to 0, so we do not need to be concerned about dividing by 0, and this will be the correct domain. Last question, using 3 rigid transformations, write g of x in terms of f and x. So you'll notice that the shape of this and the shape of this are close. What we really want to do is we want to do 3 different things. First thing we want to do is we want to take f and shift it 1 to the right. So if we take f of x and shift it 1 to the right, we essentially have moved it from where it is over to here. Now, by doing that, what we have done is we have now moved f of x to where it's defined from 1 to 3, the same as over here. Now, the second thing we have to do is we have to reflect that graph about the x-axis. Now, I'm out of room here, and I don't have room to do it, but this function right here, if you reflect it across the x-axis, will look something like that, and it'll be down below. Now, the last thing you have to do is you have to take that particular function, and you have to translate it up 4 units. So last thing will be shift up 4 units. And when you do that, you will get g of x. So let's try to do that all here in one equation. Here's how you do it. G of x is equal to, first of all, how do we do the shifting 1 unit to the right? Well, that is going to be f of x minus 1. How do you reflect about the x-axis? That's done by negating here. And finally, how do you shift that particular graph up 4 units? Plus 4. So this equation right here has g of x written in terms of f and x.